Good evening, everybody. Just letting people get into the room here before we get started. Going to have a good crowd, I think. Well, let me get started here. Good evening, everybody. I'm Reg Hoyt. I am the chair of Del Val's One Health Working Group. I think most of you have probably heard me speak many, many times about One Health, but I want to give you a brief introduction. And for those members of the community, tell you a little bit about what we're doing here at Del Val related to One Health. One Health has been really a concept that's been around since the 1800s, and really just kind of recognize the fact that the well-being of humans, uh, animals, the environment are all very closely tied together. I think it's a lot simpler than that. I think that we've got a single planet that we all live on, and the actions that we take, in particular, what we do in our everyday life, as well as what we as a species do, has impacts. And those impacts can be either positive or negative. And the blowback from the negatives is that that also affects us. The negatives to the environment and to plants and animals ultimately come back and bite us. And so, most of the time, we've looked at this from a disease standpoint, zoonotics in particular. Uh, but I prefer to think of it that every single thing we do is about One Health. Our personal decisions, our regional decisions, our local decisions. And as soon as we all start understanding that we are part of this system, this large socio-ecological system, uh, and take responsibility for what we're doing, the better off the world's going to be. And for our students at Del Val, the introduction of the One Health concept was not going to be limited to those students who are directly involved with animals or plants, but for all majors. I don't care whether you're a business major, whether whatever you're doing, you're understanding that you're part of this socio-ecological system that we call the planet Earth is incredibly important. And this One Health concept also calls for transdisciplinary or multidisciplinary interactions, meaning listen to others, get feedback from different disciplines. And I guarantee you, no matter what your major is, you're going to be better at what you do. You're going to be much more successful if you learn to listen to others and to take in information from subjects that maybe you don't normally think about. And the way we've kind of approached this at Del Val is we introduce students in their freshman year to the concept of One Health during Del Val 2 experience. And then many, many courses, including our English department, has been an incredible supporter of the One Health concept, uh, trying to get people to think more and more about this concept and how they can interact. We have a One Health interdisciplinary degree. We also have a One Health minor in One Health communications. And again, another component of this is, we've got scientists, but we need to get that information out to the people, to the people who actually take action at their local, state, national, global level. Research, well, we truly have student research at Del Val. The students come up with their own projects, and then we as faculty mentor their activities. I really challenge you students to find a group of people from different majors and truly come up with a One Health research project. Dr. Shanko and Dr. Cohen would be really happy with you for doing that. And then finally, outreach. And that's what this evening is all about. This is our fifth One Health seminar of the semester. We've been doing this now for over 10 years. We have an incredible library of talks at that link below, delval.edu/onehealth, one word. Uh, and then to top it off this evening, we have another incredible speaker, and he just happens to be a damn good friend of mine. So I'd like to introduce Don here. Oh, wait, no, I'm sorry, it isn't Don. It's Dr. DonEMoore, is a
Please.
wildlife conservationist and animal behavior specialist for over 40 years. Don't you think it's been longer than that, Don?
Yeah,
Okay.
for sure.
Don has been leading and training the next generation of animal care professionals and conservation biologists studying behavior and well-being of animals in zoos and in nature. His foundational philosophy is that wildlife species and their habitats must be conserved locally and globally for the benefit of future generations. Dr. Moore most recently worked as director of the Oregon Zoo. Before that, Don was a Smithsonian Associate Director and Senior Science Advisor and Smithsonian's appointee to the Federal Animal Emergency Management Group that studies and monitors emerging zoonotic diseases in wildlife globally. Prior to the Smithsonian, he worked for the New York Wildlife Conservation Society's zoos as a city zoo director, curator, and animal enrichment programs leader. Don facilitates collaboration between zoo and field biologists in 1WCS projects in North and South America. Moore co-founded the Cooney Hunter College Animal Behavior and Conservation Graduate Program for conservation and zoo professionals. And I know that we've got a bunch of zoo science majors and conservation and wildlife science majors on this evening, and I'm sure you're going to enjoy Dr. Moore's talk. It's all yours.
Thanks, Reg. Hi, everybody. So I just want to take you on my professional journey of working as a wildlife biologist with a foot in the field and from a zoo perch. And this is very, very specific to zoonotic, epidemic, and pandemic diseases. And so I wanted to give you my perspective from kind of the very beginning on. And Reg, this is not moving. There we go. So Reg has already gone through One Health. This is from the One Health Commission at the UN, in case you haven't seen that graphic. But I firmly believe in collaboration and coordination between the public and the private sectors, collaboration around human scientists, animal scientists, and ecologists, so that we have a result of the healthy ecosystems, healthy animals, and healthy humans. And this is the problem, right? We have too many people on the planet, and we've got habitat loss. So this is a project that we were doing at Oregon Zoo when I was there. And what you see is, I can't remember if this is a piece of Indonesia or Malaysia, but they're both doing the same thing in the Southeast Asian tropical rainforest. It's coming down, and really the line is this firm between the original rainforest and the palm oil plantations. The result of that is this large-scale habitat conversion. I mean, we've converted our prairies to corn, right, in the North America, and so they're critical of that. We can be critical of them, but the result of this is that wildlife, elephants, orangutans, tigers, snakes, pangolins, civets, bats, they all lose their homes, and the result is conflict at the human wildlife interface. So this is the beginning. Yeah, that's me when I had hair, and we had a very small zoo in Syracuse, since been renovated. But one of the ways we're reaching people's heartstrings in the public so that the zoo could be renovated and could be a modern accredited zoo was that we did a lot of wildlife rehabilitation, 300 to 400 animals per year. These days, I would not be hand raising any kind of ungulate fawn without gloves on and possibly without a mask. But that was then. This is now, 50 years later, frankly. And I also worked with foxes, raccoons, skunks, bats, weasels, and those will all feature prominently tonight. So the first thing that we kind of learned about was rabies in New York. We had fox rabies. A friend of mine had a dairy farm, and he had to put down a cow just because it got bitten by a fox. And we had raccoon rabies, and of course we had bat rabies. So when Columbus first came over to the Americas, the conquistadors and then colonists were in South America, and they brought their livestock with them. And in the 1500s and then 1600s and on, a lot of people were bitten by vampire bats. They're very, very sneaky, and they carry rabies. And they are the natural host for rabies, and humans are the end hosts. And so the result was a lot of people dying, and Europeans really, really understanding rabies. And then we had canid rabies around the world. And of course, I think we all know how rabies works. It's a lyssavirus. It's a single-stranded RNA virus. The animal bites or scratches you or puts saliva somehow into an open wound. That virus multiplies, goes into the central nervous system. The brain becomes inflamed, and there are a whole bunch of bad things that can happen if you're not treated. So here are the lyssaviruses. And the really interesting thing for me as an ecologist, when I look at these viral variants, these are all lyssavirus variants, is that if you're a lyssavirus that is specific to a bat that's sedentary, and these are vampire bats, right? And they go out and feed. And one vampire bat from one population contacts a vampire bat from another population, and they transfer the virus. They go back to their home populations. What happens? The viruses reproduce so rapidly that they're speciating, but they're not. They're creating variants, right? But if you're from one of the upper bats where it doesn't show any variant at all, that would be, for instance, a Brazilian free-tailed bat. They are migratory, and they are mixing all the time. And guess what? Their viruses are mixing all the time, and they show no variation within kind of the entire species for their virus. So I thought that was pretty cool. I thought you'd like to look at all the variants of these lyssaviruses, and of course, they can really cause a problem when they leave their natural host and they go into humans. So there's a little bit about the virus itself. It looks like a little tiny bullet. It's like I said, a single-stranded RNA virus. That's the nucleoprotein. The glycoprotein is the thing that, after COVID, you might call it a spike protein, right? And that's what helps to invade the cell membrane and actually get into the body. So I'm going to blast through that and just go to these symptoms. The interesting thing for me is that it takes so long to just fester in the body before we start seeing symptoms, right? So it's days, it's weeks. There was a young girl in Ghana where it was actually 5 years. Reg and I know that it can be even longer in bats. There were some fruit bats in Europe where there had been zero symptoms in a closed colony for 15 to 20 years. And then all of a sudden, those bats started having rabies symptoms. So in bats, which are the natural hosts, they still die and everything, but it can be a very long time between the incubation period, between the actual transfer, and then the prodromal period, which is when symptoms start to show up. And that lasts 2 to 10 days. And then with rabies, we go into, and there are a lot of symptoms that are shown there on that graphic from verywellhealth.com. But then we go into the neurologic period that lasts 2 to 10 days, usually ends with death, right? And that's where we get furious rabies. That's where we get Dracula stories from. That's where we get paralytic rabies for 20% of the cases. Their muscles weaken and stuff. But then the atypical rabies, mostly from bat bites, produces both furious and paralytic rabies symptoms. And so we know that all of these animals carry rabies. World Rabies Day is September 28th, the day that Louis Pasteur died. And in the 1880s, there was a kid in Germany who had rabies, and his mom made a plea to a doctor who was a colleague of Pasteur, and they were vaccinating dogs, but the plea was, please, please, please use that on my son. They treated him, and that was 1885, and he lived. He was still living in 1935. So while we're talking about rabies, we also need to recognize the danger of interspecies transmission of Nipah and Marburg and Hendra viruses that go from bats to humans. One note, rodents like woodchucks don't carry rabies. I know people in conservation departments that have killed woodchucks because they're acting weird. They weren't rabid. Another note, owls, we were warned when we were rehabilitating owls, we were warned by Cornell University Vet School that we should be very, very careful. There's a very, very small incidence of mechanical transmission of rabies from carnivores like owls or cats that eat a rabid bat or a rabid skunk or maybe a rabid raccoon baby or whatever. And they've still got that rabies virus mixed into their own saliva, or they're carrying it. And it'll live, a couple of days outside of the body given conditions, right? So environmental conditions are important there. But what's our preparation for that? Well, increased understanding of wildlife diseases and zoonoses. And while I was working at Syracuse, at the same time that we were being prepared, there was a bat researcher who was in a cave who was breathing the aerosols in the cave and actually then had to be treated for rabies. So we all got vaccinated and we all were using PPE. And by the way, the vaccine now is so efficacious that WHO, World Health Organization, now says it lasts for a lifetime. So that's pretty good. It confers lifetime immunity. And then I just want to know that bats on other continents like Europe and Africa have these recently described lists of viruses, and they're not neutralized by antibody responses to existing vaccines. So PPE in the global south is even more important for bat researchers. I want to jump from bats and dogs to our arthropod friends for a minute here. That's a tiger mosquito, Asian tiger mosquito, and they've invaded here and they're moving north. Thank you, climate change. And so mosquitoes, so arboviruses are arthropod-borne viruses. Part of my undergrad was medical entomology, so I had to work with mosquitoes, actually put our arms out and get bitten by mosquitoes, but they transmit Eastern equine encephalitis, malaria, dengue fever, chikungunya, yellow fever, West Nile virus. Not so bad until you get to, the ticks and the one that makes you allergic to red meat or just causes an even worse disease. So, but I'll talk about mosquitoes. We'll leave the ticks behind here for a minute. So here's Eastern equine encephalitis. As a New Yorker, I'm mostly interested in what happens in New York. And in a 50-year period, 24 upstate New Yorkers were diagnosed and several died. And one specifically was a child in Oswego who died in 1971. And that gave me a summer job as an entomologist student. I was doing mosquito control. And so here on the left, you see the Culiceta mosquito, which is the enzootic vector. And the enzootic cycle goes from that mosquito to birds, native birds that are the amplifying hosts. And then there are other mosquitoes, Culex and Aedes species, that are bridge vectors. So they are mosquitoes that are not so specific to birds. They bite everything, right? So we were trying to control Culex and Aedes, and they would go and they would bite these, like a robin or whatever, and then they would go and they would they deliver the EEE to a horse, and they deliver EEE to humans, and 30% of sickened humans actually die of EEE. So you can see it's a low number, but it's still concerning. And we could see pheasants and chickens that had been infected with EE because they do feather pecking, and there's feather pecking transmission from bird to bird. So really interesting. But for humans, how do you reduce your chance of infection? If you're outdoors, you use bug spray. We don't have to constantly spray, but as Reg said, we're trying to protect the environment as well. But my job was to reduce aquatic breeding sites. So if we saw tires hanging there and they were full of water, or we saw a trash can that was not turned upside down, or even bottle caps. I mean, these mosquitoes will breed anywhere, and their eggs only take 3 or 4 days, given the right environmental conditions, to actually hatch out. So I'm jumping from there back to 1999. I was in the New York City zoos later on, and I thought I understood something about mosquitoes. And then we had crows and blue jays dropping out of the sky, literally dropping out of the sky into the zoos. And, the 5 New York City zoos, the Bronx Zoo, the New York Aquarium, the City Zoo, Central Park Zoo, Prospect Park Zoo, and Queens Zoo are all under the Wildlife Conservation Society umbrella. And they have a great veterinary core team that also has veterinary pathologists. And so our rule was, as zoo people, hey, you got dead wildlife on the zoo grounds, pick them up, bring them to the Bronx Zoo, and we'll do the necropsies on them, and we'll tell you why they've died and if our animals are at risk. And so this is a virus that was originally isolated from West Nile province in Uganda in 1937, right? People knew about it. And our pathologist at the Bronx Zoo, Tracy McNamara, had gone through the U.S. Army Medical Research Institute for Infectious Diseases, USAMRID. And she was the one doing this, and she thought, well, this is strange. It's an encephalitis for sure. It looks like a flavivirus. I'm going to send it off to the viral labs, the U.S. viral labs in Iowa. And so she did, and it came back Eastern equine encephalitis. And she thought, I don't think so. And we had multiple crows and blue jays who were exquisitely sensitive to this disease, who were going in for necropsy. And so she sent it off to USAMRID. She called a friend and she said, I think the US vet lab is wrong on this one. Could you look and tell me, is this West Nile or not? Because I think it's West Nile. And so sure enough, it came back West Nile, and I'm sure you know everything that happened after that. It went across the country. It killed a lot of American New World birds because it was a novel virus to them, and they had not evolved with it. And so what's our protection? Well, we tried to get rid of the mosquito, right? But we also needed to protect the birds in zoo collections. It's transmitted by 3 species of Culex mosquitoes, and it's just a nasty disease to get, because you can have muscle pain, you can have rash, you can have swollen lymph nodes, and some people died from it, right? So a bizarre little thing here, as I was researching it just for this presentation tonight, is that some guy in the 2000s suggested, well, there were Egyptian Rosetta's bats that were, these are small fruit bats, that were identified as having West Nile virus back when, and some came in by mistake in 1994. And so the US government had, Reg, you'll appreciate this, had kind of bypassed the permit process and allowed 1,000 Rosetta's bats into the country to be pets and be sold at pet stores. They were so protective in terms of zoos and having any kind of fruit bat, because they could decimate our fruit production in the United States. That I'm skeptical about this, but his suggestion is some of those got away and they introduced West Nile into the country. I think since ground zero was Queens, New York, and LaGuardia Airport is right there, and Kennedy is nearby. Our thought was that, hey, this came in on a mosquito or a person who came from one of those countries in the Middle East and brought it, or in Africa and brought the disease with them. But same thing, control the mosquitoes. So I want to jump to primates. One of the things that I did while I was, working in zoos was we managed a lot of primates. And of course, we've got hundreds of species globally. There are the great apes in Africa and Asia. There are the lesser apes, the gibbons and siamangs in Asia. There are the prosimians in Madagascar and Asia. And then there are the monkeys, the old world monkeys in Africa and Asia, and the new world monkeys in South America. And guess what? All of them carry a herpes virus. So the first herpes viruses that you see are human herpes simplex. So that's our cold sores, right? I have herpes simplex. It's mostly latent in me, but if I get stressed, I get a cold sore, right? Macaques carry macaque herpes virus 1, which is also called herpes B, and that is latent in them. But herpes B transmitted to humans is deadly, potentially deadly to humans. Our herpes simplex transmitted to tamarins is potentially deadly to tamarins. So even though all the monkeys seem to have their own herpes virus, if they're transmitted to some other species where it's a novel virus, bad things can happen, right? So one is called the samarine herpes virus. Its natural host is squirrel monkeys. It's transmitted orally or fecally. And in natural hosts, it's either asymptomatic or they can have oral lesions. In the susceptible species, marmosets, tamarins, owl and titi monkeys, also from South America, transmission's a little bit easier. It can even be aerosoled, and susceptible species have all the symptoms right up to death. And there can be 76 to 100% mortality in those susceptible species. So we don't have any data available on treatment, but possibly antivirals will work. And the prevention is just strict separation of natural hosts and susceptible species, including equipment, right? Due to the risk of indirect transmission. So when I say clean everything, as a zoo curator, I'm saying clean everything, boots, clothes, yourself, whatever, right? Here's a little diagram of kind of the coevolution of herpes simplex across, or herpes viruses across the different species, right? So at the top there, we have 2 in red, and those are our herpes simplex viruses for humans. The next one is a chimp virus. I won't go through all of them, but the next 3, MHV1, that's herpes B, right? So we have to, presume all of these are zoonotic and assume that all the primate species have them. We should wear PPE, again, clean everything. And then the best thing is to separate susceptible species from host species. So keep the old world monkeys away from the new world monkeys, away from the prosimians, et cetera, et cetera. So after WCS, I went to Smithsonian for 10 years, and I just want to give a shout out to Smithsonian Conservation Biology Institute. They have hundreds of projects around the world. One of those lines down to Uruguay, South America is mine. But you can see we did a lot of work in Africa, in Asia, in India, and from our home base in Washington, D.C. And a lot of that started with behavior work by some really famous behaviorists, Eisenberg and Kleiman, and it evolved into ecological and disease research and biodiversity monitoring, even professional training. And I want to jump there. As I jump to Smithsonian, I want to jump to herpes again, sorry. but they were the saviors of golden lion tamarins. And in the 1970s, there were 200 animals. By 2026, this year, there are 4,800 in the wild and 500 in human care. The threats are habitat destruction of their Atlantic rainforest in South America, and disease. And the disease threats, like I said before, herpes simplex from humans. So if I had an active cold sore, I was not even allowed near the tamarins. If I had just latent cold sores, latent herpes simplex, I still wore a mask because I didn't want to even come close to transmitting disease. They can also get herpes samurai from squirrel monkeys and others. Callitrichid hepatitis will also kill lion tamarins, apparently. They can get rabies. And a yellow fever kind of epidemic for tamarins caused the loss of 30% between 2016 and 2019. So they were up in the 3,000s, they went down to 2,400, and now they're back up to 4,800. They breed well. But we have a very, very big focus on their behavioral and physical health. And so the restoration of these golden lion tamarins is a model for other mammalian reintroductions, and that takes into account One Health. So behaviorally, we did captive breeding, we did pre-release behavior indexing, and then the reintroductions. There were NGOs in the US, in Europe, in South America that reconnected healthy habitat in the Atlantic rainforest for these creatures up to 60,000 acres so that at least 2,000 could always be in the wild. And the veterinarians were involved because they did health assessments pre-release. They did fecal cultures looking for toxoplasma, salmonella, shigella, things like that to make sure these animals were clean. There are actually 2 quarantine periods before these animals go back into the rainforest. One is at kind of a halfway house zoo, and one is before they even go to Brazil. They get vaccinated for rabies and tetanus, and they have TB tests, and they have tests for human and CBID herpes virus. So the clean animals are the ones that are okayed for reintroduction. You can imagine the collaboration across this program to make all of this happen. Sorry, I'm staying on herpes. So Smithsonian discovered a disease called elephant endotheliotropic herpes virus. It's actually been reclassified as a proboscis virus because it's only found in elephants. So this virus has been described going back to possibly the 1800s. When we look at the literature about what the disease looked like in calves and adults, and even in the old Indian literature from hundreds of years ago, it may be described there. But the signal case was an elephant calf named Kumari who died in 1995 at the National Zoo. And the National Zoo worked with Johns Hopkins University and other zoos with an elephant research focus, including Houston Zoo and Oregon Zoo, which is this photo of a bull in Oregon, to lead the way to not only kind of test for EEHV in these elephants, because it sits in a latent form. We now think that maybe it sits in the bone marrow. Remember, our herpes sits on the end of a nerve, right? But maybe elephant proboscis virus sits in the bone marrow until it emerges and produces symptoms. But they're also leading the way in producing an EEHV vaccine, because it turns out that this disease kills a lot of elephants, both in zoos, in circuses, and in the wild. So by the 2000s, Indian and Sri Lankan researchers were starting to collect dying elephants or dead elephants in range country. And we, Smithsonian, helped them set up a lab that's a lot like the National Elephant Herpes Lab at the National Zoo in Washington, D.C., and they set it up in India so that the Indian biologists could take a quick look at their elephants to see if these calves were dying. And it's about 20% of the calves that are affected by herpes, and most of them die. So when I was at Smithsonian, we already knew about avian TB. We knew about bovine TB. Working in zoos, you're focused on disease. You're focused on healthy animals. But we were asked by the Malaysian government to do some work at some reserves and help get these elephants out of trouble in the reserves and design sanctuaries for them. And so that's an elephant that had been in human-elephant conflict at a palm oil plantation in Malaysia. And we found out that working with our colleagues, our medical colleagues, and our biological colleagues in Malaysia and also in the United States, and that many captive and some wild Asian elephants had elephant tuberculosis. It turns out that elephants and humans have been working together for so long, 5,000 years or more, that elephant TB is human TB. So when we looked at, with colleagues, places in Malaysia and in India where humans and elephants had been in contact for a long time, and I think in Thailand, it's about 24% of the elephants have TB that's identifiable. We teach elephants to do trunk washes, we take blood and things like that, and we can identify that they have TB, at least TB titers. The same number of mahouts have TB. So at Oregon Zoo, we had a male elephant. He had been the first male born in the United States in, I don't know, over 100 years. It was 1964 that he was born. When I went there, he had TB. A keeper had TB. She had been treated. She was fine. He was not fine. He had gone through 2 courses of drug treatment, 2 different drugs, and the idea was to go to a 3rd drug. Well, he was already resistant to the 2 drugs, and he was a very compliant elephant, but these drugs hurt. And so we were worried that he would not be compliant with drug number 3. And if he was resistant to 3 drugs, we would be creating a tuberculosis that was multi-drug resistant, because being resistant to 3 drugs is multi-drug resistant. And so in the end, the entire team determined that elephant should be humanely euthanized. We did not even do a necropsy. We didn't want to expose the veterinarians to it. It was too dangerous. And so he was buried with a ceremony in Oregon. So elephant and human TB is a pretty big deal. That's it's a very, very quiet thing, and it's not good for the elephants or for the people. So TB, I want to emphasize, it's ubiquitous across mammalian species. And of course, One Health considers the interconnectedness of health systems across species. So because it's a zoonotic disease, we have to pay attention to the environmental health, the animal health, and the human health. And that One Health approach allows us to better understand the transmission pathways in elephants and therefore prevent TB in humans and other animals, because that same TB can be transmitted to chimps and tapirs and rhinos and you name it. So we needed a collaboration between veterinarians, public health doctors, occupational health professionals, and ecologists to consider the result and to consider all of our TB testing that we now do. So I want to fly back to the Americas here. I want to talk about AI here briefly. That on the left, you can see snow goose flock from Delaware in the winter this year. That flock was about 12,000 birds. I usually go out and try to count at least 1 flock a year. 2 Delaware poultry flocks were depopulated this season, but in 2025 overall, 30 million laying hens were culled in the United States due to HPAI. HPAI is the most egregious of all the avian influenzas. So it's H5N1 What happened with H5N1 was it emerged in 2020. It's a variant of all the avian influenzas, all the flu influenzas, and it started in Europe and moved to Africa with the death of thousands, tens of thousands of seabirds. Then it moved across Africa and apparently into India and Asia, and then hit North America in about 2022, and then moved down the coast into South America. And of course, as it was replicating so fast, think about evolution, it was creating real havoc in the wildlife populations. And it was a novel influenza virus, so it killed a lot. So on the very bottom right, you can see those guys in white suits. That beach is not a pebble beach between them and the ocean. Those are all fur seals. All those little dots are fur seals. What you see in the upper picture on the right is a trip that I took with 12 people down to Argentina with Argentina biologists to see the remnants of the elephant seal herd. So that beach in 2022 would have been full of elephant seals. And during our trip, we saw a couple of dozen. This mammal to mammal transmission is brandy new. So it's an epizootic. It's not a pandemic. It's localized, kind of. It's in non-human populations, right? It's jumped to humans a couple of times, but concerningly, it's jumped to marine mammals and between marine mammals. So it's pretty bad. So this is a graphic of how it moved. As I said, it came in 2022. There was the first detection in northern South America of the disease. It moved down the west coast and infected not only birds, but mammals, sea mammals, all the way down and around. So think about the ecology of these creatures. Pelicans go in groups, dolphins go in groups, seabirds go in groups, seals and sea lions, elephant seals, all are in big groups. So they're all close together. And even the geese and swans traveling in groups. So again, the big concerning thing about this was that not only was it moving from birds to birds, but it was moving to mammals and between mammals. So protecting these birds during HPAI, we exclude flocks from spaces where wild or migratory birds, especially waterfowl, have access. We disinfect equipment, footwear, vehicles, and other items prior to any contact with captive flocks. So think about zoo exhibits. Every single exhibit now has its own set of tools, or should, and we isolate sick animals, and we have to depopulate flocks if there's exposure. Otherwise, more animals get sick, right? So, all right, I'm going back to the bats. They're just reservoir hosts for so much. You'll probably remember Middle Eastern respiratory syndrome. You'll remember SARS. You'll remember SADS, which is swine. The disease syndrome, and aerobic maybe. And then, so finally, the SARS-CoV-2. So we know who the natural hosts are. They're bats, right? We know who the intermediate hosts are. In MERS, it was a dromedary camel. In SARS, it was a palm civet. We know that there was, quote unquote, swine flu. All of these can be then transmitted to people who are the end hosts. For the SARS-CoV-2 COVID, it was probably civets and non-human primates. Let's just forget about, where it originated. It originated in whatever way in horseshoe bats. That's what we know. Whether it went through a lab or not after that, I don't want to argue about it. Okay, so coronaviruses that are pathogenic to humans come from these ancestral bat viruses. And so what you see there with the coronaviruses, you can see the little spike proteins, and you can see the nucleoprotein protein on the inside that are the coronaviruses that then move to us and cause big problems. And what happened with the COVID was that it was such a novel virus for us, and it was able to do human to human transmission that we got sick from it, and a lot of people died. So what do we do about that, right? We do a lot of PPE, and you can see at the bottom of this graphic the number of animals that got sick: dogs, lions, tigers, cats. We were being very, very careful with any kind of mustelid, any kind of civet, mongoose. So all the felids, all the canids, and especially our closest relatives, the primates. So we were in zoos, we were suiting up and trying to make sure that COVID didn't jump from us to these animals, even though it did. I think that was before all zoos kind of had a protocol of, okay, everybody's got to wear gloves, everybody's got to wear masks, everybody's got to wear full face shields. I mean, whatever that is, we would step that up with each event. And then just remember, please, please, please wash your hands often. One solution I think is safe habitats. So that's zoos are involved in doing that around the world, so that both at home and globally, so that we can kind of protect nature, because a healthy nature probably is the best thing for healthy animals, and hopefully keeping animals there. I love animals, but we don't need constant contact between us and the wildlife. And I just want to do one shout out. Zoos are doing a lot of work with kids, and mostly we're doing it with these small animals. So this is a picture at Oregon Zoo. We were working with Western pond turtles. We were taking our zoo teens out to help have them release the pond turtles. And I was like, wow, why aren't they wearing gloves? Every time you touch a reptile, you are at risk due to salmonella, unless you're properly trained in hygiene and mitigating getting a disease. So not only that, but they're in a tick habitat there. And so they could be getting Lyme disease. So my goodness, I hope they've got, some kind of spray on, as well as they're going to wash their hands afterwards. But we know these turtles are endangered due to overcollection and habitat change. And so we're getting kids involved in saving them. And that's all great, as long as we do it safely and keep the kids healthy the entire time. Oops, sorry. And that's all. Thank you so much.
Thanks, Don.
Reg,
Folks,
thanks for giving me so many diseases to talk about.
hey, wait a minute. It wasn't me that gave you the diseases. They were kind of there. Folks, if you have any questions, please put those in the Q&A, and we will make those available to our guest. And I'm not even seeing my Q&A at this point. Let me see.
Do I have to stop the share to do that?
Excuse me?
Well, I'm stopping the share.
Oh,
Can we see
yeah.
Q&A then?
Now we can look at your house and everything too. Go ahead and put your questions into Q&A. And so I have a big question for you, Don.
Sure.
How did we survive all these years working in zoos and working in the field?
I don't know. My mother was sure I was going to die. I mean, seriously, I can throw out a number. Rabies. I think 40 to 100,000 people die of rabies every year. 125 to 140,000 people die of venomous snake bite every year. I have no idea how I survived that. I never got bitten by a snake, but so I guess my point is, sometimes the physical danger is worse than, the disease danger, but I think we have to take safety precautions for both, right? But fortunately, you and I are still alive. I don't.
Yeah, no, we're just hardy folks. I think that it's really interesting looking back to the early days of our careers and what we were looking at, as far as you were showing pictures of, hand raising deer, and you worked with all kinds of animals, institutions I worked at had wild caught raccoons and skunks and all kinds of stuff that were being not only hand raised, but then used for educational animals. Uh,
Yeah.
and, I know during one of my careers or one of my jobs, going into an institution and going, no, we are not using native mammals for education purposes, and in introducing our interns, our students, and the public to
Yeah.
all these disease risks. And they were like, well, nothing ever happened. Well, when it does happen, it's bad.
Right. Well, and that brings up a really good point, and that's about Asian macaques, right? From the time you and I started to now, a lot of zoos have gotten out of Asian macaques. Why? Because one lab worker got, I think she died back in the 70s, back in the 80s, um, from herpes B, right? We put in PPE precautions in place and everything, but people were just so nervous about the liability. Great. But if you think about Asia, there are Asian monkeys everywhere
Mhm.
throughout Asia. People are exposed to them all the time. Are we just not seeing the people that die of herpes B? It's not a pandemic of herpes B, right? So it's a very, very limited number of people that are sick or dying from herpes B in range countries with constant exposure to these creatures. I mean, they run around markets, they run around
Uh,
restaurants,
yeah,
the
yeah,
monkeys, not the people.
yeah.
So,
We have
yeah,
a question from
yeah.
Alexis. Why does the elephant herpes virus need to infect bone marrow rather than infecting the nerves like it does in other animals?
I don't know. I'm not a virologist. I'm an ecologist. I can tell you until recently, they didn't even suspect that. They just said, we don't know where EEHV lives when it's latent. We can't find it. So an elephant's a big creature. It's hard to find. Um, and so in humans, I guess with all the research that we've done on herpes simplex in humans and non-human primates, we know that herpes simplex lives on, the tip of the nerve when it's latent, and then when it comes out, it goes into the rest of the body, right? But I mean, wherever it goes. Most non-human primates and humans that have a herpes simplex, when they have mild symptoms, they get some kind of mouth ulcers, which is what I get, right? I get a sun blister. But for elephants, they get lethargic, they get huge, they get swollen, their tongues swell. It's a different reaction to proboscis virus than it is to herpes simplex.
Sue Ferreira is on, and she says, hey, Dr. Don, it's Dr. Ferreira. After having had conversations with you about burying animals, why was the elephant with TB buried and not cremated? Would the TB not leak into the ground or leach into the ground?
Yeah, we put him in a place that's fully controlled by the government and will never be touched. It's a great question, but to cremate something as large as an elephant, you would have to cut it up, and we did not want anybody cutting it up. That's a good question.
I have a horror story to add to that, Sue. And I'm not going to name the institution, but the institution before my arrival had an elephant die from TB. They chose to bury it above ground. They just covered it with dirt.
Hmm.
And then it became an elephant ride area, and elephants and camels with people on them were ridden around that lump of ground every single day.
Wow. And Rich, did any of those animals ever get TB?
Not that I'm aware of. Not that I'm
Wow.
aware of. Um,
I would have been nervous. Yeah.
yeah, well, I worked in the area and I was very nervous to go over in that area and certainly didn't want anything to do with that particular piece of ground. Uh,
Yeah.
there were some odd things that occurred at that particular institution. And in that same institution, we had actually acquired a an opossum from, it was a pet, kind of like the problem with the Egyptian fruit bats, and it ended up transmitting avian TB. Uh,
Wow.
and so I had to depopulate all of the birds that I had in a particular building because of that particular animal.
Wow.
Again,
Well,
not
we
really
should
being
say
that.
for people that don't know, zoos, professional zoos have at least a 4-week quarantine usually. We've gone to risk-based quarantine now. So for instance, if you're moving a sea lion from one zoo and the entire herd at that zoo is healthy and you move it into your zoo, say Central Park Zoo, it needs a social companion more than it needs to be quarantined. So maybe it gets isolated in the same building with the other sea lions so it can see and hear them and things like that. But normally, especially for snakes, for birds, it's a 30 to 90 day quarantine so that they don't infect the rest of the population. But it's hard to see avian TB. So,
Yeah. And this animal had been a long-term pet and then went through a quarantine period, and then later on, uh, it died of avian TB. So um, it was not a nice surprise. So we're
yeah.
getting close on our time here. Any more questions? Otherwise, I'm going to ask my big question.
Oh,
It's not that hard, Don. I think you won't have any trouble with this at all. I think that, Don, both of us have gone through our careers. We working in zoos, working in the field. Uh, and I think for many of our students, they are thinking about, well, I want to work in a zoo. I want to be a keeper. Um, and then we've got other students who are saying, I want to be conservation and wildlife management students. I want to work in the field. I have held the belief throughout my entire career that these are not two separate entities. There's a
right.
continuum here. And that,
Yep.
if you're working in a captive situation, you have to be well aware of what's going on with wildlife as well. And if we're going to achieve conservation, like we saw with the golden lion tamarins, this is a partnership. It's a partnership of not only being able to breed these animals and have them ready for introductions, but then all of the work that goes into preparing them and then getting them out in the wild. Golden lion tamarins, one of our first SSP, uh,
Yeah.
has really demonstrated the power and the value of zoos and that cooperation with those folks in the field as well.
Yeah. Yeah. And more zoos are doing research and conservation these days since you and I started in the
Mm-hmm.
profession because we've strengthened the accreditation rules about that. So even 15 or 20 years ago, a zoo could say, "Oh, I'm doing conservation. I just gave, $50 to the Elephant Trust."
Right.
Well, now you have to maybe give $5,000 to the Elephant Trust for habitat conservation and send your keeper over to the Elephant Trust to help with whatever they're doing uh, in the field or protecting elephants. So it's a totally different kind of collaboration between professional AZA accredited zoos or CASA accredited zoos in Canada and the wildlife group. I just wish more wildlifers would go into zoos and embrace zoo-based conservation because there's such a good background education there in things like wildlife disease, wildlife ecology, wildlife behavior that it's very it establishes a very good foundation for the rest of your career. And at the same time, if you're on the zoo side, you can go into a national park and just think of it, hey, it's a big zoo,
It
and I'm
is.
going to keep all of those people away from those, say, bison at Yellowstone.
Well, I think there's been an amazing shift. When you and I first started in the business, the thought of working with either a state agency or federal agency, we would often get a cold shoulder.
Yeah,
that there was thought, no, you folks are working in captivity. No, we work in the wild.
yeah,
And
that's
that
right.
has changed dramatically to them more so. There still are some who are reluctant to work with zoos, but at the same time, I think there's been a recognition again of that continuum that we can be a heck of a resource. Zoos can be a heck of a resource
Yeah.
for those entities.
Well, right. And with, anthropogenic climate change these days, and habitat change, we're all in the kind of emergency room together doing intensive care, so they may be doing intensive care on the habitat side, we're doing intensive care on the wildlife side and put them together. And that's, you've got two pieces of the One Health spectrum right there.
Right. Well, our time is up. Don, it has been a pleasure having you on our One Health seminar. For all of you folks, this is my last webinar with One Health. We still have two more in-person events. Tomorrow night, we've got one at the Life Science Building with Ann Bilkey. And then in a couple of weeks, we've got our final one with the Doylestown Borough Climate Action Group to talk about their climate action plan and plans for the borough's development into the future that actually pays attention to climate change and what our roles are in dealing with it. Don, remember, I know a great Mexican restaurant. Come on up.
We'll
We'll
be
go to dinner. All right, everybody. Have a great night. We'll see you later.